Hello. Today's video is going to take you through a little bit of practice on searching and also some string methods, because what's coming up is another test coming up, and it's the final test of the year other than the final exam. And this test is going to go over the searching notes that we did recently. And it's also going to have some string stuff. So way back to MagPyLab, we did stuff like substring and index of, stuff like that. So I wanted to do just a quick string methods review before we jump into this packet, but you can write this right on this packet. Hopefully you have this packet in front of you. The first thing I want to do, just off the side, like I said, I'm going to do some string method review. Okay, so let's say I'm going to make a string. We're going to call this string S, and I'm going to call this string basketball. Right like that. Okay, now remember there's a substring method, and there's two ways I can use it. Since the string is called S, if I wrote S dot substring, and I just wrote S dot substring 6, think back to MagPy, what does that do? Remember, a string is kind of like an array in that it's indexed. So B is at index 0, A is at 1, S is at 2, 3, 4, 5, 6, 7, 8, and 9. Okay, there's 10 letters in basketball, and they're indexed 0 through 9. So if I say S.substring 6, that's 6 is the first spot you're going to be. If you ask this to print out, it would print out ball. So if I have one number inside substring, it starts at that index and then just goes to the end. I can also put two things in here. If I said S.substring 06, what would that print out? Well, again, it would start at the first number, so starting with the at space 0, which is B. The weird thing about it is the way this is written, 6 isn't the last index, it's the first index you don't want. So it's going to go 0 through 5, because it's not going to do 6, so it's going to give you basket. Like that. Okay, now what else can happen? We also have this thing called index of. If I ask for S dot index of, and you can put any string inside here. So let's say I want to know, where is ask in basketball? So what that would do is it would give you where that substring, that little piece, is within this bigger string, because again, it's still referencing S with S dot. So ask is right here, ASK, and it starts at space 1. So this returns an index, a spot, and it's the spot where this starts in S. So this would return 1. Now, what if I did S dot index of asking? So even though ask starts at index 1, asking is not in basketball. So if the string you're looking for isn't in S, what would it return? -1, similar to searching when it doesn't find what it's looking for. It returns -1, and that just means it's not in there. Then finally, one that you use a lot, S.length. Remember, when you're dealing with a string, length does have double parentheses. When you're dealing with arrays, it doesn't. But S.length would tell you how many spaces are actually here, and even though it goes 0 through 9, that's actually 10 spaces. So the length is still 10. Okay, so I only did that quick because these substring index of length, those string methods will be on the next test, and they're also going to show up in this practice packet. Okay, first part of this is about binary search. So notice there's a integer array called A. It's a private int instead of public. Don't worry too much about that. It's something you'll hear about in AP. This does binary search on an array. It's already sorted in ascending order. Remember, binary search has to be sorted. Ascending means it's getting bigger as you go. And this is going to return the index that's equal to key. So key is kind of like the value you were looking for. And notice it's not sending you the array A because it's just made out here, but it's searching for a specific value. And this is exactly the same as what we did in our binary search notes with a couple slight changes. I put mid out here, and also I put mid in both of these else ifs, but it's the same code every time. So you can actually not put mid in all three places and just put it here, because then no matter what, it'll happen every time before it runs one of these searches. Okay, so anyways, other than that, this should look exactly the same as what we had in the notes. So a binary search will be performed on the following list. So here's an array. There's the values that are stored within it. Why don't you pause the video? If you were in class right now, I would have you pause and try 9, 10, and 11 on your own. This is just like the examples I did in the notes. So why don't you hit pause, give these three a shot, and then when you're ready to see the answers, hit play, and I'll go through it, and you can see how you did. This will be good practice for your test also. So hit pause. Do it. All right, you ready to see the answers? Okay. So again, binary search is given to you here as reference. To find the key value of 27, which notice is not in this list, what is the search interval after the first pass through the while loop? Remember how binary search works. Initially, low is the first element, high is the last element, and it finds mid by doing low plus high divided by 2. And I'm talking about the index. So when I say the first element, it's the index of the first element, so 0, and the index of the last element, so 7. So for mid, if I do 0 plus 7 divided by 2, that's going to be 3.5. But remember, in comp sci, integers are going to lop off the decimal part. So index 3 is going to be the middle. Okay? So it's going to search just looking for 27. So it's going to compare. Is 11 greater than 27? Or first it'd say, is 11 equal to 27? And no. Is 11 less than 27? Yes. So you could use the code up here if you wanted, low equals mid plus 1, so low equals this now. Or you could just think, well, if this is smaller, I want everything to the right, because that's where 27 could still potentially be. So after one pass through, you can see we went from A4 to A7. So initially, low was 0, high was 7, and mid was 3. And after that first pass through the while loop, low changed to index 4. High didn't change at all. High stayed at 7. So we're searching from A4 to A7. That should have been C. All right, how many iterations will be required to determine that 27 is not in the list? Okay, well, again, what it starts at doesn't really count. Low is 0, high is 7, mid was 3. That was before the while loop started. Now we know after one pass, low is going to be 4, high is still going to be 7. What would the new mid be? Well, you would do 4 plus 7, which is 11, divided by 2 is 5.5, so mid's going to be 5. So there's our mid value. Okay, so the second time through the while loop, it's going to check, is 5 equal to 27? And again, it's not. 27 would be to the right, so 27 is going to be over here somewhere. So low is going to change again. Now the lowest value I need to check is the 6th spot. High is still 7. What's the new mid going to be? 6 plus 7 is 13, divided by 2 is 6.5, but again the 0.5 gets lopped off, so it's just 6. So this is low and mid, but we're still going. Third iteration through. It's going to check, is this spot equal to 27, mid? And it's not. So whenever it's not, whenever it's too high, you're going to look to the left of it. So since this spot was too high, high changes to mid minus 1. So now the third time through, high went to mid minus 1, and since mid was at 6, high's at 5 now, which means low did not change, low's at 6, and what just happened? There's that crisscross. Low and high can't crisscross over each other. So that would end the while loop, and it would tell you 27 is not in the list. So how many times through did that take us? 3. Now most of the other answers you could rule out. You know it's not going to be 1. After 1 passed through, we did that in number 9. I hadn't found whether it's in there or not yet. How could it possibly take 27 times to get through 8 numbers and decide if it's there or not? So 27 is a ridiculous number. 8's kind of ridiculous too. 8 would be how many times it would take linear search. Because linear search, remember, you have to look at every single value. And there's 8 of them. So the only one that makes sense, because it's not all the values and it's not one of the values, it's got to be 3. And it is. Now 11 is actually really easy. What will be stored in Y after executing the following? So it's binary searching, and the key that it's looking for is 4. So look at your list. Where's 4? There's 4. What index is it at? Index 0. So that's what's stored, 0. Don't overthink it. It's telling you what index is that at. So it boils down to, can you find that number in the list and tell me where it is? Ease peas, right? Right. Okay, next page. All right, here's some string review. Consider the following program segments. So I have S1 is a string, and it's race car. S2 is just car. And I want to print out S1.index of S2. So that means you're looking in race car. So here's S1, race car. And let's show the indices also. This is 0, 1, 2, 3, 4, 5, 6. So when I say index of S2, I mean I want to look in S1, where is car? And car is in here, so right here. Remember, index of returns the index where it starts. So it starts at spot 4, B is 4. Good? Okay, index of. Okay, now same idea. I'm starting with race car, that's S1. Let's just write that out again. With the indices 0, 1, 2, 3, 4, 5, 6. S2 is initially nothing, just a blank string, not even a space. And what this does is it starts with k equals 1. It goes all the way up to the length of S1. So k is going to go from 1. What's the length of this? It's 7. But it's going to go less than that. So it's going to go 1, 2, 3, 4, 5, 6. And every time, S2 equals S1.substring 0 and k. So the first time this runs, substring 0, 1, it would give you just R. Because it would start at 0, 1's the first one you don't want. When k is 2, so it's R when k is 1. When k is 2, it's going to go from 0 to 2. It's going to start at 0, 2 is the first one I don't want. So now S2 is RA. And you can see where this is going. When it does 3, 0, 3, it's going to start at 0. 3 is the first one I don't want. Now it's RAC. Notice I'm crossing off what it was every time. Because it's not plus equals, it's equals. So if it's equal, it's actually setting it equal to that new value and overwriting the old one every time. You'll also notice I haven't talked about this yet. This is outside the for loop, and this is that, I don't love it when they don't put brackets. But remember, if there's no brackets, only the first line actually happens in the for loop. So this just prints once at end. But it only prints out once at end. I'm never actually going to see these other ones. The only one I'm going to see is when it's 6. So 0, 6, it would start at 0, but 6 is the first one I don't want. So it's going to be race car, like you're from Boston. That's it. So these other ones, this is what actually happens in D, but they don't print out because they only prints out the last value of it, which is race car. Questions on that one? Make a note to ask me if you do. Otherwise, here we go. Okay, another new method. Again, don't worry about these things like static, that's stuff you learn in AP. Just look at the actual code. So you're given a string. T is an empty string to begin with. This time I'm starting at the end of the string, going down to 0. And this time there is a plus equals here, so T is going to keep adding on to something. And we got the question, what string value is returned by a call? Question, so this method, I'm sending an aardvark. So S is aardvark. Okay, and let's get our indices. So this is index 0, 1, 2, 3, 4, 5, 6, 7. Okay. K is going to start at s dot length minus 1. So the length is 8, so minus 1, K is starting at 7. And we have T plus equals s dot substring. So when K is 7, we've got s dot substring. And it's giving me K, which is 7, and 8. What's that going to return? Okay, so that's just starting at 7. 8's the first one I don't want, which is good. So this is K. And remember, it's a plus equals. So T initially was just an empty string. Now I added K onto it. Okay, K is going to go down. So now K is 6. And you'd have s dot substring again. K is 6, K plus 1 is 7. So now I'm starting at 6. 7 is the first one I don't want. So I'm going to get R, but not K. That's a plus equals. So it's going to add on to what was already here. Now there's also an R there. Okay, let's do one more. When K is 5, it's going to start at K to K plus 1, 5 to 6. So starting at 5, the A. 6, R is the first one I don't want. So again, that's just A. So already you can see that there's only one answer that works. It's going to be E. Because by the time I get down to 0, we'll have 0, 1, which is going to be the first A there. So you're getting aardvark spelled backwards. Pravdre. Make sense? Okay. The number 10 is very similar. A lot of it's the same. I start with an empty string, I'm going backwards through, but the thing that's different, in the last question I had K and K plus 1 here. Here, in the substring, I don't have K values. Instead, I have constants. What's s dot length minus 1? Well, if I'm giving it aardvark again, it's a length of 8, so minus 1 is 7. So this is always going to be 7, and s dot length is always going to be 8. So every time I'm adding on s dot substring, 7, 8. And what was s dot substring 7, 8? It was K, because 7 was the first number I wanted, 8's the first one I didn't want, which doesn't exist, so K. So since this just keeps running and just keeps putting on K's, what's going to happen is K is going to get added on every time. So it's C. So that change, not putting variables here, means I'm not going to get anything different. I'm just going to get the same letter every time. Make sense? K, 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 K. All right, I'm going to read through number 14 and then see if you can try it. This is one of the rules of converting English to Pig Latin states. If a word begins with a consonant, Move the consonant to the end of the word and add AY. Thus, dog becomes ogday, and crisp becomes rispk. Suppose S is a string containing an English word that begins with a consonant, so it can't be a vowel. Which of the following creates the correct corresponding word in Pig Latin? Okay, so think about what has to happen. I'm starting with dog. The first thing I need to get, my goal is to make this ogday. So I have to take from the first index to the end. And then I want to tack on that first letter. And then I want to tack on AY, because Pig Latin always ends in AY. Read through this. Which of those will do that? Hit pause and give it a shot. All right, ready to try this? Okay, let's use my dog example again. This is 0, 1, 2. And again, if you haven't taken time to come up with an answer, I would really suggest you pause and try it before I tell you. How would I get og? That's a substring. So to get OG, we would take a substring, and I'm always taking off just the first letter. So I'm going to start from index 1 and go to the end. Now I could just say substring 1 because that automatically goes to the end. Looks like none of these do that. So what would I say for og? 0, I'd start at 1 and go until the first one I don't want would be space 3, even though that doesn't exist. So just from that one, it can't be A because I don't want the first letter. I don't want to start at 0. So C is out also. Do I want S dot length or do I want S dot length minus 1? Well, what's S dot length for dog? It's 3. And that's what I want here. The first index I don't want is the first one that doesn't exist. So I do want S dot length here. So B is still in the mix, but D is out because that's a problem. So far we've got B or E. Okay. Now I want this first letter, E. How am I going to get that? Well, it's another substring. And I could also use char at. If you remember char at, it's going to be char at 0. So if that makes sense, you could use that, but that's not what any of these choices do. But the first letter I want is at space 0. If I just want the D, what's the first one I don't want? The O at space 1. So this is substring 0, 1. So this one says substring 0, 0. That's a problem. That's out. This one has substring 0, 1. So this is it. You see the last thing they do is they add the A string on, which was another variable they made. So it's called AY A string. Make sense? I certainly hope so. All right, last page. This question refers to the getString method shown below. So I'm given two strings, it looks like, S1 and S2. Index is S1.index of S2. And then I return a substring, index plus S2.length. What is true about getString? It may return a string that is equal to S2, has no characters in common with S2, is equal to S1. Now this is one you might have to do some thought on. Let's start by describing what it does in words. And this is something that, a trick you can use on multiple choice if you're able to. So describe in words what it does. So basically you're finding where S2 is in S1. And then you're taking a substring, starting from that index, and going the length of S2. So it's essentially pulling out S2 from S1. Pulls out S2 from S1. So let's do an example. Let's do something that has the word in the other string. So let's use race car again for S1 and car for S2. Index is going to equal S1 dot index of S2. So where does car start? This is 0, 1, 2, 3. It starts at space 4. So index would equal 4. And it's going to return a substring, S1 dot substring. And it's going to return index 4, comma, index plus S2 dot length. So what's the length of S2? 3. So that 4 plus 3 is 7. So it's going to return, starting at 4, 0, 1, 2, 3, 4, and 7 is the first one I don't want. 4, 5, 6, 7 is the first one that doesn't exist. So it's going to give you back car. All right, let's see if that helps us narrow down at all. It returns a string that is equal to S2. I'd say that's equal to S2. So 1 is definitely true, which means B is out and E is out. Can it return a string that has no common characters in common with S2? Well, that's returned car, and it has letters in common because it's the same, so it can't possibly be 2. 1 and 2 are kind of contradictory to each other. So anything with 2 in it's out, and all of a sudden A is all that's left, 1 and 3. How could it ever return a string that's equal to S1? Well, what if S1 and S2 were the same? What if S1 was race and S2 was race? What would index be? In S1, where does race start? Starts at space 0, so index is 0. So now I would have S1 dot substring, starting from the index value of 0. Going to index plus S2 dot length. What's the length of S2? 4, so 0 plus 4 is 4. So starting from space 0, 0, 1, 2, 3. First space that doesn't exist is the first one I don't want. So it's going to give me race back. It may return a string that's equal to S1. That's how it happens. Now, would it ever be able to return a string that had no letters in common? Some people think, what if the two words are totally different? What if I had race and I had Bob? Nothing in common. So what would index be? In S1, where does Bob start? It doesn't. So what does it return if that's not in S1? It would return -1. I would get substring, S1 dot substring. The index would be -1. And S2 dot length, the length is 3, so -1 plus 3 is 2. But I can't start at index -1 because there is no -1. This would give me an error. It would not return something that has no characters in common because it would stop and give you an error. Okay, so that's why it's A, 1 and 3 only. All right, let's look at 14. I'll use a different color here. So here we've got string S. It returns a substring starting from 1. Here I've got a string S, and it returns a substring starting at 1, as that one, but then going to S.length. For which values of S is the same value returned by both methods? What happens if there's not an ending value here? It just goes to the end, right? If the string was race car, 0, 1, 2, 3, 4, 5, 6, this substring 1 is going to start at 1 and go to the end. So you're going to get ace car. This is going to go to 1, and the length of race car is 1, 2, 3, 4, 5, 6, 7. It's going to start at 1. 7 is the first one I don't want. So starting at 1 is A. First one I don't want doesn't exist. This one's also going to give me ace car. And it wants to know for which values of s is the same value returned by both methods. Well, here the same one was returned. It says only whenever s is a string with one character. Well, that's not true. This had more than one character, so A's out. For all string values of s, could be only whenever s has an odd number of characters. Well, 1, 2, 3, 4, 5, 6, 7. Okay, this has an odd number. If there was an even number, if I put another one, if I called it race cars and made that go to 7, now the length is 8. This would return ace cars. 8's the first one I don't want. It would still return the same thing. So it doesn't matter that there's an odd number of characters. Is the same value returned for no string values of s? Well, no, because I found one is the same, so D is out. Only for string values of s that are palindromes. Now, race car is a palindrome because it reads the same forwards and backwards, but race cars is not a palindrome, and it still gave me the same thing. So E is out. It must mean that B is the answer. Any value of string, any s value, is going to return the same thing because these two methods essentially do the exact same thing. All right, last one. I'm going to read through this and have you try it again. Again, I've got two methods, similar methods. I'm sending it two strings. Here, I'm saying, where's that second string in the first one? And here I'm saying, where's this first string in the second one? So I'm looking for the second string in S1, and here I'm looking for the first string in S2. For which values of S1 and S2 is the same value returned by both methods? I would pick some values, pick something for S1, pick something for S2, and see if you can come up with an answer. Hit pause, give it a shot, and then I'll show you what the answer should be. Ready to see it? Okay. I want to have something where one of the words is in the other one. So let's call this one S1, we'll do strawberry. And S2, I'll do just berry. S1.index of S2. So in S1, where is S2? So here's 0, 1, 2, 3, 4, 5. This would return 5 because berry starts at space 5. This one says in S2, in berry, here is strawberry. Where's S1? And strawberry is not within berry, so what gets returned here? -1. For which values is the same value returned by both? So the same value is not returned by both here. Whenever the first character of S1 is the same as the first character of S2. Okay, can't do anything about that one. Whenever the last character of S1 is the same as the last character of S2. Well, here the last characters were the same, and I did not get the same value returned, so B is out. For all string values of S1 and S2, are all of these, well, here's an example where they don't give the same, so it can't work for all of them because I found some that don't. For no string values, is this never going to return the same number? Potentially. Whenever S1 is equal to S2. Let's test out this last one. Let's say S1 is car and S2 is car. Here's 0, 1, 2, 0, 1, 2. So this first one would say, where is car in car? And it starts at space 0. So this would return 0. And this is asking the exact same thing. When is car in car? Again, this car starts at space 0. Return the same thing. Okay, so I can't say that it never returns the same thing anymore. D is out. And it does return the same thing whenever S1 is equal to S2. The one I haven't ruled out is A. Would it always return the same thing whenever the first character of S1 is the same as the first character of S2? I could do that really quickly by calling this cars. So now they're different, but the first characters are the same. Where is cars in car? It's not. So this would return -1, whereas car in cars starts at space 0. So this one returns 0. So this doesn't return the same thing. And if you think about it, it should make sense. If S1 and S2 are the same, then the index of them and each other are also going to be the same. So it's choice E. All right, so I hope that gave you some good practice. After this, the next thing is going to be a test. The test, again, is going to mainly be on these string methods and the new searching notes that we did. That's all I got. Have a great day.